Thank you for joining us for today's webinar, Scheduling for Dummies. I'm Jay Corey, Senior Events Manager here at Deltek. Joining me today is Tom Poland, Director of Solution Architecture at Deltek. Welcome, Tom.
Hi, thanks for the introduction, Jay, and getting everyone set with the proceedings here today. Yes, my name is Tom Poland, Director of Solutions Architecture here at Deltek. I haven't always been at Deltek. Actually, I've had positions that are quite relevant to the topic at hand today, scheduling for dummies. I've been in various scheduling, program control, cost analyst roles for almost 2 decades, and only recently have I come over to Deltek to talk about these processes and solutions. What I'll try to do today is not only show you the great content that we have and talk about that, but relate some of my own personal experience as well as to what's worked well for me in scheduling and what hasn't worked quite as well. As Jay mentioned, please feel free to make generous use of the questions box, the chat window on your GoToWebinar control panel. We actually have Jen Weber, a member of our Deltek team, who is going to be monitoring the questions throughout, and she'll be answering many of the questions as well. And at the end, what Jen will do is she'll ask me some of the top questions that have come in, either some of the most frequently asked questions or some of the most insightful questions that we have, but she will try her best to get back to all questions that you do have. So we want it to be interactive. Obviously, we've muted all the attendees, but you can use the chat window to help make it interactive. So let's go ahead into the material here. And before we get into this and talk about what is a project and how you can measure the effectiveness of your project and your project schedule, I do want to mention what we are and what we aren't talking about today. What we aren't talking about is the building blocks of CPM scheduling. Now, don't get me wrong. We're talking plenty about critical path method, or what I'll call CPM scheduling through the session, just not down to the detailed technical level of how the system calculates. If you're using one of the popular scheduling tools out there, this system is helping you do that. Now, we're more than happy to share those nuts and bolts, and we'll be putting up contact information at the end of the session. What we're going to assume, our baseline assumption today, is that you either have or you're pursuing a tool that performs this CPM scheduling process, but it's using a lot of terminology, all of which you may or may not, be familiar with. And then also, one thing we'll be really focusing on today is what some of the limitations are of these tools in terms of what they'll let you build. In fact, they're very generous about the types of projects and plans that they'll let you build, which is good. I don't want my scheduling tool telling me how to build my project. I want to build my project. But at the same time, the downside for that is you could build a completely unrealistic plan, and the system is none the wiser. Well, we want you to be wiser, and you to have the tools and resources to be able to say, this is a good plan, or this is not a not so good plan. So I just wanted to set that stage. Let's talk about what a project is and define some of this terminology. A project by its nature, and you'll see this definition quite a bit, is that it's a unique temporary endeavor. It has a start and a finish date. It's not something that goes on as a sustaining activity. It's something that we can look at measurable criteria and say, once these measurable criteria are accomplished, the project is now complete. If we don't feel like we can say that, we need to relook at what we're building and whether it does indeed have milestones that can be accomplished. If it doesn't have milestones that can be accomplished, it may still be considered an effort, but it won't be defined as a project. And we use the term in here, achieve a particular aim, and everybody on the team should be very familiar with the definition of that aim being met versus that aim not being met. I don't want to ask half the team if the project is done, and half the team says yes and the other half says no. There should be an extremely clear definition. We're going to use a cooking or baking example today. Everybody should know, everybody involved in baking the cake should be able to look at the product and say that is a complete baked, iced cake with a candle on it ready to deliver versus not being in that condition. One thing that I like here is number 4. and this is often misinterpreted as well. Projects spend money, they don't make money. Now, your goal may very well be, by investing in the project, to make money as a result of the completion of the project. But the goal of what you're doing and what you're creating will cost time, money, and resources. It's not just you're not just doing things that are just going to instantly, automatically be profitable. A project is an investment. Many of us, or maybe even all organizations, expect a return on that investment, but the project itself is the investment piece. Project management, the discipline of doing this, the discipline of managing the investment of time, materials, and money. And that's what we're going to really get into detail on today. And there will be details. It's not all going to be high level like this, I assure you. Managing those components, time, materials, and money, and measuring them and understanding if we've set realistic expectations for their use. That's really the heart of today. Here we are. We're baking a project cake. I'm not much of a chef. I don't do well in the kitchen, which is good because that helps me really understand these bullets that I have up here on the screen. It is very possible, maybe even probable, that I will use the wrong ingredients when I'm cooking something, so I want to have everything well staged. When I cook, I need everything set out and measured out beforehand, and I need somebody else to double check that I didn't use the paprika when I need to use something else. See, I don't even know what ingredients are. Didn't correctly estimate the the quantities that are required. The right ingredients in the wrong amounts are the wrong ingredients. And my favorite here, number 3, you didn't plan for the anti-plan. You didn't plan that the yeast was going to be expired. I didn't plan that at a higher altitude, the cooking times would be different. In fact, some of these things I didn't even know or realize until Jen told me about these yesterday. Now, the right ingredients for a project. I'm hungry for cake right now, but we got to talk about projects. These are the ingredients. Here's where we're getting into a little more detail here. And these are some of the terms that you may have already seen or will see in your scheduling tool of choice. The project itself, it defines the start and finish of the entire effort, and it encapsulates the defined work. The project is a roll-up. It's a summary of all the components beneath it. And right beneath project, we have activities. These define duration for a given scope of work. Activities have a name. As we talked about resources down below, activities have resources assigned to them. That's not a mandatory step. You don't have to add resources in your scheduling tool. But if you do, it helps insulate you from creating a situation where you're requiring work get done in a period of time that you don't have the resources available to complete in that period of time. So I can say that something takes 5 days, but if I don't have 5 resources, if I only have 1, it might take 25 days. Only by assigning those resources may I understand that. Otherwise, it's all too easy and all too convenient to say it's going to take 5 days, but not really ask myself the question, do I have the resources for that? Logic links. Every activity falls somewhere in the project. Every step in bringing a recipe into a product, into that cake, has to be done in a logical sequence. I can't bake the cake until I put the ingredients together and mix them a certain way. I have to use the right mixer depending on what I'm making, either a hand mixer or an automatic mixer. Automatic mixer. See, I don't even know what these things are called. Electric mixer. If I decide just to list the activities and not list them in a logical sequence, I have a list. I don't have a schedule or a project. Schedule by its nature implies that there is a sequence or a right time to do certain things. Well, if I don't have that schedule, I don't know when I'm doing certain things. Now, there's a right way to do this, and there's the not-so-good way, which we'll be talking about in a few minutes, which is why we don't assign dates to activities. In fact, you won't see the term dates listed as one of these items on the left-hand side. We want the dates to come to us by determining what the activities are, how long they take, and what sequence they should be performed in. And that brings us to calendars, as we're talking about dates, which is when I have resources available to me. We don't always have resources available on Saturdays and Sundays. So when I see a project that has a 7-day-a-week calendar, 24 hours a day, I become skeptical pretty quickly because I don't necessarily believe that the project team has resources available to them to do this work 24/7. Maybe they have 5 days a week, 8 hours a day. Maybe they have 9 days across 2 weeks, 9 hours a day, which is becoming increasingly popular. 980 type schedule. This is something when I'm validating schedules I'm always looking for, because we could have a realistic plan, but if we have unrealistic work times, if we're counting on resources being available during times when they're not at work, we're creating a recipe for failure. Constraints. These are where you decide that March 30th is the date for something and you put that into the schedule. Well, what if the sequence of tasks leading up to March 30th are too long and they're trying to push past and they're putting pressure on that March 30th date? Well, should we in fact have overridden when the scheduling system would have calculated this time? Or are we justified in putting that March 30th date because that's where we've committed this work would be done? And if we have and it can't be done by March 30th, well, what have we done? What have we accomplished? We haven't necessarily used all the resources, all the scheduling resources available to us to come up with a realistic expectation of when work could be completed. Resources, I talked about this a little bit earlier. The best made plan can be undermined by the inability to have resources assigned to what we need, when we need it, and the right resources for the job, the right type of engineer. It's one thing to have an engineer available, but are they an expert in the work that I'm asking them to be able to perform? So if we're baking a cake, I am not the best resource. I am an available resource, but I might not be the optimal resource, and we might need more resources on that cooking activity if I'm the primary resource that's available. The right resource or the wrong resource at the right time is the wrong resource. The wrong resource at the right time is, yeah, I said that right, sort of. And that goes to resource assignment. Link the correct executors, the people who can do the work, to the work that they should be assigned to. That's not easy. In fact, none of these things happen overnight. And these are things that can always be improved upon. You can always have a better, more realistic calendar. You can always further optimize your resources. You can always, if you have constraints, you can always look for opportunities to reduce or eliminate them. And you can always revisit your scheduling logic to make sure that that sequence truly is the sequence that events need to happen. So I don't want to be discouraging here, because obviously, you know, depending on your experience, you might be seeing terms that you're either not familiar with or that you're familiar with but you have not really gotten into the art and science of, and that's okay. Because with the approach we're talking about today, it is an incremental approach. It is a maturation approach where it is fundamental to understand and use these things, but we have systems that can help us understand whether we're using these in a realistic fashion, even if we don't have everything perfect the first time through. In fact, in defining a schedule baseline, you'll never have the ingredients perfect on your first pass through creating that baseline. We're going to talk in a moment about a maturity framework. Now, the moment I say maturity framework, that implies that's something we're going to do iteratively to get better, faster, stronger. And that's exactly what we're going to talk about today, which is this project maturity framework, where we fall in this. And this also gives us a sneak peek at some of the upcoming Dummies sessions that we have coming up over the next few weeks. So let's talk about this maturity framework. S1 is the base, or the baseline. It's a non-validated schedule with unknown realism. Every plan that I make for everything that I do starts out with unknown realism. It's a shot in the dark. Maybe it's a shot in the gray. Maybe I do know some things, but I don't know everything at this point. That's okay. That's where it all needs to start. We're not going to have the perfect plan the first time through. Now, the mistake, the problem that we've seen in the past, and the problem that we're trying to solve here, is that oftentimes that first shot in the dark or in the gray has been treated as gospel. And the team would go ahead and attempt to execute to that plan. Now, what would happen very quickly in project execution, and I've done this myself dozens of times, is within several months, that baseline plan is treated without a whole lot of respect. Oh, there was so much we didn't know back then. Oh, okay. Oh, guys, the baseline's obsolete. We didn't have the assumptions built into the plan. Things that we know about now. Things that we didn't realize when we baselined the plan. If we were baking a cake, we didn't realize it was a slower, older oven. We didn't realize that the ingredients needed to be fresher than the ingredients that we acquired. We didn't realize that a certain type of flour was needed, so we just bought any type of flour off the shelf. Once again, I'm showing my cooking ignorance. I don't even know if there's different types of flour. So one of the sins of my past was starting but also stopping at this S1 phase and not doing the heart of what we're talking about today, which is critiquing the schedule, using system-level diagnostics, using expert human resources to look qualitatively and quantitatively at the schedule to determine if it has trouble areas, where they are, and what the highest priority problems are to solve right now, and what the problems are that can be solved in the schedule over time. This is something, this is the first problem we set out to solve several years ago, is we ourselves had been working with a number of schedules where in hindsight, it was never the right plan to begin with. Well, hindsight is cool, but that doesn't help you win the day. Foresight helps you win the day. So if I have a way, if I have methods to critique my schedule while I am developing it, so we can say, hey, what are the things that are going to run this project off the rails? Let's fix it now before we run into those problems in execution. That's a nice conversation to have up front before we start spending time, money, and resources. Now, in the coming weeks, we're going to be talking about S3, S4, and S5. S3 follows right along from S2, which is risk-adjusted. What are the things for this type of project that we know can and maybe will be problems? What are the threats? If I'm driving to work in the morning, what are the chances of a traffic jam? What are the chances of an accident or inclement weather during my drive? We don't get a lot of rain here where I live in Arizona, but when it does rain, in fact, we've been in the news for this recently, when it does rain, you might not be able to physically get to work. Well, what's the cost of that? Maybe it's easily measurable, maybe it's not. Well, your project has those same challenges, and although they might not happen every time, every year on every project, there might be certain things that have a known possibility or probability for your type of project that you want to model into the plan rather than treat as an unanticipated emergency when they do happen. Again, back to that foresight, knowing what can happen and what the measurable impact may be if it does happen. As for optimization, this is coming up in a couple weeks as well, taking those risks into account, knowing that there might be a rainstorm on the way to work. Well, what are some of the things you can do to make sure that you can still get to work on time? You can check the weather report. You can get up a little bit earlier if you do see an inclement weather report. You might find alternate means of transportation or alternate means of doing your work that won't require transportation. But again, thinking about those things beforehand and building them into the plan instead of them being surprises every single time when they do happen. S5, which in some ways runs throughout all these other phases, having the team understand what's in that schedule, having them review their individual confidence in it so that they have the right information to say, thumbs up, we can proceed with this plan. We've anticipated the problems, and we have plans to mitigate them. If everybody on the team can say that, I'm pretty confident. If the team hasn't addressed risk, or only some people have, and I only see some people with the right information to buy into the plan, that's when I get a little bit nervous and I feel like I'm still back at S1 here. I need everybody to move together and understand the inputs and outputs to each of these maturity phases. Now let's really get into some of the nuts and bolts. I promised you today this wouldn't just be high-level PowerPoint bullets, and here's where we're really getting into the terminology and how you use it. Step one is building your schedule. The schedule needs, this sounds really basic, but I see this done wrong all the time. The schedule needs to reflect the actual work needed to achieve the overarching objective of the project. I see a lot of project plans that make a lot of resources really busy, but I can't always map those individual activities that the resources are performing back to the statement of work of the project. That means one of two things. Either the schedule was not built with the project goals in mind, or the project goals were too ambiguous to be able to develop a specific detailed plan. And that's, for me, from my experience, that's the more common case, is the team really, really did want to build what it is the stakeholder was expecting, but the stakeholder wasn't clear on their goals. They weren't clear enough to have a detailed plan developed to meet those goals. And that brings us right over here to project objective. What are we building? If everybody in the room had to draw a picture of what the objective looked like, would everybody draw the same picture? That's kind of silly. Okay, you know, what are we going to do? Give everybody in the room crayons? Honestly, it's not a bad idea depending on what you're building. You might learn some things right there about the team's understanding of the project. Project scope. What are the performance goals? What are the cost goals of this project? Is what we're going to do to meet the project objective really in the scope of the plan? They do tend to go hand in glove, the objective and the scope, but again, the clear communication and flow down of that objective to then the more individual things needed to deliver to meet that objective, and that brings us down to the deliverables. The list of features. If you're shopping for a computer, there's all kinds of different features available to you. Well, which are the most important to you for what you need to do? And those might be different features compared to what I would need in a computer or a car or anything that you're buying. It might be important to somebody to have a fast car. Well, it might be important to somebody else to have the highest seating capacity. They're both automobiles, but you need the automobile that fits your needs. It's the same thing with projects. You need the project deliverables that are actually going to bring you to those objectives. If your objective is to transport the highest number of people possible, you need a bus, not a sports car. The WBS further, or work breakdown structure, further breaks down those deliverables and assigns them to different product-oriented areas. And then beneath that is the activities, and subordinate to those are the resources needed to do the work. This can fall apart anywhere in here. You can have the right resources working on the wrong work. You can have the right work that meets the scope of the project, but you didn't either have the right resources or any resources to actually perform those work. Your company might be an expert in something, but if you're working over capacity, you won't be able to deliver for that next customer. So when you're thinking about these, especially down to the resource level, it comes down to more than planning an individual project. You need to look at your whole portfolio and say, yes, I am competent at delivering this type of work. Am I competent at delivering this type of work right now, given the other resource constraints that I have for the other customers that I'm trying to satisfy? So scheduling just got bigger for us now. We're scheduling not just at the individual project level, but we're dealing with constrained, potentially constrained resources at the broader portfolio or enterprise level, and we need to take that into account as well. It's very easy in the scheduling tools to assign resources, to go through the physical act of assigning a resource to an activity. It's a broader question to say, well, do I even have that resource available at this point in time? If not, how do I get the buy-in from that organization so that I do have that resource? So this is like, right here, this is like a chain. It's only as strong as the weakest link. I can be strong up here, but if I'm weak down here, it doesn't matter. It will all fall apart. Now let's talk about dates. I made a reference to this earlier, so let's talk about what I really mean. It is very easy, and I think everybody starts out this way when they build a schedule, whether or not they realize they're building a schedule. You make a list, and you put finish dates on when you need to get things done. I do this every morning with my daily plan of what I need to do. I do it with my Outlook calendar up on the screen. Every day is kind of its own unique project. Well, okay, that's easy. You know, you can do that in your head. Well, what if you have a project that has 10,000 individual things that need to get done in order to get the project done? It would be quite a tall order to sit down, list out 10,000 items, and then put dates next to each one of them. And by the way, you would have to do that every day, because the moment one date changed on one activity, you would need to change all the other dates for the 10,000 items. At least in most cases, you probably would. So why not have a computer do that? And let's train the computer on how your project is executed by telling it what the activities are, how long they'll take, and what the sequence of activities is. And then we can have the system come back and tell us what the dates are. In fact, it doesn't just give us one date, it gives us a few different dates. And I'll define these for you at a high level right now. There's early dates, and there's late dates. I was trying to think of a metaphor for this morning. I always like to relate this stuff. And I was in bed, and my alarm clock was ringing. And I set my alarm clock too early. I would have loved to have gotten up at about 4:15 a.m. when I set my alarm clock. That was my early dates. That was about the earliest that I could wake up today and still be functional, was about 4:15 in the morning. Now, I also knew that I didn't have to get up at 4:15 in the morning to be up and ready and broadcasting this webinar. But there was a drop-dead point at about 6:45 where I absolutely positively needed to get out of bed or I wouldn't be talking to you right now. I wouldn't have done the sequence of events to get ready for this webinar. So my early date, the earliest I could feasibly get up was about 4:15, and the latest I could get up was about 6:45. Now my float, it's normally the number of days between the early and late date. In this example, the float is the number of times that I could press the snooze button on my alarm clock. All right, let's not be silly. I don't have an alarm clock. On my phone, between 4:15 and 6:45. That's how much time I have between my earliest possible and my latest possible is the float. So if you have a scheduling tool now, you'll see that float field in there. That's what it means. It's how much slack time you have. I gave myself too much. 4:15 to 6:45 is an unreasonable number of times to hit the snooze button. But that's what I have. Now the baseline, we say here baseline early and baseline often. That should be the optimal time. If I get up a little too early, maybe I'm too tired and some things take longer. If I get too late, I'm running too hot against the baseline. And if anything went wrong, if I got up as late as possible, I'd be off plan, I'd be off the baseline. So maybe there's a sweet spot between 4:15 and 6:45 for me to get up. That sweet spot, in most cases, should be my baseline date. That's my target, that's my plan, that's what's going to get me there optimally. Now, I might have some target dates that have no bearing on the schedule, but those are kind of nice to have dates. I'm fine with that. It's not something that I use very much, but I need to make sure if there are target dates, I need to make sure that they're somewhere in the range of the early to late dates, and maybe they're in line with my baseline dates. Finally, constraint dates. Again, I want the schedule to tell me the dates. When I'm entering constraint dates, I'm undermining the schedule calculation because I'm telling the schedule when things need to happen or when I want things to happen. That's dangerous because it can conflict with the scheduling calculations, and it's not something that I want to do very often. Importance of a sound schedule. At this point, I hope we've made this somewhat clear, where if I don't do these things, if I don't sequence my activities, then I don't have the system telling me the right dates. If I don't assign resources, I don't even know if I have the people, time, and money to get the job done. I've made a plan that's not, if I do those things wrong, I've made a plan that's not really a plan. I've made a plan that might look nice on the wall, but it's not really something we can manage to. And that's the most important question we can answer, is do we have a schedule basis that's critiqued, that's taken risk into account, that we can actually manage to and have a possibility or even probability of success with? That's a tougher question to answer. I'm going to talk about some of the ways we can answer that. Now, traditionally, what's happened, I've been involved with this many times, is we either send out a Gantt chart or we print one out with a plotter and we put it on the wall. Everybody takes turns walking up to it, nodding their head, saying, ah, yes, good plan, good sequence. So let's draw a line from here to here. Well, for a large plan, even for a mid-sized or a smaller plan, it's a very difficult exercise to do just by staring at the Gantt chart. It typically looks like what I have on the right side of the screen here, and it looks nice. It's actually not as helpful as we think. And the reason is because I've done this. The reason I say that is I've done this a number of times, and the Gantt chart at the end of the project doesn't look anything like the Gantt chart at the beginning of the project. It means we didn't plan well. Why? This was too complex to be able to look at qualitatively one by one and make any sense out of it. Let's talk about a better way, and employing qualitative and quantitative schedule diagnostics so that we don't have to stare at the Gantt chart. We have the system staring at the Gantt chart for us, but it's using objective means, things that it can calculate and look at to be able to determine the quality of our schedule. It can analyze the outputs from the schedule, cost and risk models. We can't build in quality just by measuring, though. We need to build quality into the source. So we're going to talk about that too, and how we do that, and how we pinpoint these hotspots, and proactively find shortcomings, issues, overruns, trends in our schedule that will not be obvious to anyone just by staring and following the lines on that Gantt chart. Computers can do thousands of things a second compared to us following one line on the Gantt chart. So we want ways to leverage that. We want to use thresholds. We know everything's not going to be perfect, so what tolerance for imperfection do we have before we really start getting nervous? And trending, one of my favorites, something can be nominal, but if we see it approaching our tolerance thresholds, let's do something about it now before it crosses those thresholds. Okay, I'm talking about data. What does this mean? What does this mean to our schedule? Honestly, I could change the heading of this slide, put this in front of any Lean or Six Sigma oriented organization, and it would make sense. So let's talk about these measures of quality with respect to scheduling. Now, there's a lot of metrics out there. I'm not going to talk about a lot today. I'm actually going to talk in detail about between 9 and 11 different metrics. But where do these come from? Well, there's all kinds of best practices out there. In fact, there's hundreds, maybe even thousands of best practice metrics, ways of measuring your schedule out there. We even focus in our tools on 300, and that's not near all of them that are out there, but we try to focus you further down from there, and those are the ones that I'll be talking about today. There are standards for PMI, AACE, NDIA. The GAO has metrics. We have some of our favorites called logic density, hotspots, and redundancy. What does that mean? There's compliance metrics. DCMA has this 14-point assessment. Within DoD, there's even far more than that. And on top of that, you can create your own metrics, either using tools or not using tools that help you understand what's going on in your plan. And then to work backwards on this slide here, we have schedule metrics, we have cost metrics, performance, characteristics. If you're doing earned value management, that's its own art and science with hundreds of metrics that you can use to measure earned value, and then risk metrics as well. So the problem we run into when we start taking a metric-based approach to schedule realism and schedule quality is we can find any number of definitions of quality out there, and within those definitions there can be hundreds of metrics as well. And our noble effort to bring some consistency and standardization to metrics can lead us to frustration or even a boiling point where we don't feel confident that we're measuring the right things at the right times because it's alphabet soup here with all these different types and categories of metrics, and then these terms that I'm putting up on the screen like Hotspot. Well, that's another problem we wanted to solve. In our Deltek Acumen toolset, one of Deltek's products, family of products, we decided that we needed to boil things down to make it easier and more optimal to measure your project, to measure your project's realism and your project's performance, and measure these over time to make sure that things are staying nominal or finding out right away if they're getting better or worse. So to do that, I put some of these metrics up on the screen, and some of these I'm going to be expanding on in a few minutes. We have things like logic density. How much logic are you using in your schedule? Are there hotspots, activities where all sorts of other activities converge into them, where you're waiting for 100 people? What's going to happen if you're waiting for 100 people to do something before you can begin your work? Some amount of them are going to be late, which means you're going to be late. Well, let's spot that beforehand and do things now before later on you realize that you're late. Float ratio, redundancy index, finish compliance. Let's define some of these. We've, through experiment, through empirical knowledge and wisdom, looking at real projects over time, thousands of projects, we've learned what the habits of more successful projects are versus unsuccessful projects. And we've used hundreds of metrics to evaluate these habits, and we've come up with 9 that are the strongest indicators of schedule quality. Successful projects do these 9 things better than projects that are unsuccessful. Unsuccessful projects tend to do these 9 things very poorly. I'm going to specifically define these 9 items today, and then even a couple more if I have time. Number 1, missing logic. When we see schedules that are missing sequenced logic, we see schedules that didn't make it. We see schedules that didn't meet their stakeholder dates. In fact, when missing logic exceeds 5% of activities in the plan, we see a project failure almost every single time. If the events don't have a sequence, if that recipe for baking the cake just lists the ingredients, but not the order in which to use the ingredients, we won't have a cake. I certainly won't. You might have that inherent wisdom, but I won't be able to follow the project plan if it's just a list of ingredients. I need a sequence of those ingredients in which they're used, and I need instructions for each one. So if that's missing, if that sequence is missing, my project has failed, my cake project has failed before it even begins. Number 2, logic density. This is almost the opposite if it gets too high. Now, it can be too low. If I'm missing logic, I'm going to have a low logic density, which means each activity doesn't have a sufficient number of links. But this works both ways. If you give me a recipe that's so complicated that each ingredient goes in, the use of each ingredient takes me in 5 different directions after I use that ingredient, that means I've got to do 5 things at once, and I'm not going to be able to do that. At that point, we've added too much complexity to my cooking plan. So the logic density can be a problem in either direction. You either haven't given me enough instructions, or you've given me so many instructions that I'm paralyzed, and I have too many things going on at once, and I start making mistakes. We see an optimal level of logic density around 2, 1 predecessor, 1 successor for every activity. That's a sequence that humans can follow. If I start seeing 5 or 10 inputs and outputs on every activity, we lose track. It becomes very difficult to manage, and people end up starting their activities late for reasons that they don't even understand, because there were too many inputs to their process, and frankly, they don't even understand why some of those items were inputs to their process, and they feel like they could have started sooner. But the schedule didn't plan to have them start sooner, so we didn't have the resources available at that time. Number 3, the number of critical activities in a schedule. Your schedule will and should have critical activities. What does that mean? That's activities where if they slip a single minute or a single day, your overall project will slip a single day. Let's talk about driving to the office. It's something many of us can relate to. If there is an accident as I'm driving to the office, I probably won't be able to make up that time. Maybe if traffic clears up and I'm willing to go a certain speed over the speed limit, maybe I can make up that time, but ordinarily, a minute sitting in traffic is a minute late in reaching your goal. That's a critical activity. Driving to work is a critical part of getting to work. Whether or not you turn the radio on, that's non-critical. The music you listen to might make you happier and slightly more productive at work if you're happier, but you don't have to turn the radio on. You can still get to work on time. When we see schedules that have more critical activities, you're indicating that the schedule has a higher risk. If there's 10 things that I need to do to get the project done on time, and any one of those could slip my plan immediately when it starts slipping, that's a highly critical schedule. If my project has 10 things to do, but only 3 of them will really push out the end date, that's not so bad. That means as resources are constrained or if there's problems with the other 7 activities, I still might be able to deliver on time. This is something we look for in those successful projects, is what percentage of the plan was on the critical path. We get nervous when the whole plan appears to be on the critical path and we see a schedule that's likely not to be achieved on time. Therefore, it's an important thing to measure both at baseline and while you're executing the plan. Hard constraints. We treat these as a no-no because you're then controlling the system and the calculations instead of the system interpreting your logic, interpreting the plan, and telling you the dates. So what's the consequence? Inaccurate finish dates, lack of insight to schedule changes, risk events, and earlier delays. What does that mean? That means when you give the system a date, it's unable to put pressure on that date. So if leading activities, upfront activities slip, you won't see them accurately reflected in the finish date of the project. Now, I understand management challenge and maybe even challenging the team to results that they haven't previously accomplished, but that needs to be done sparingly and it needs to be done realistically. Every time I see a hard constraint, I challenge it. I'm willing to leave it in, but there needs to be a good answer. It can't just be, well, that's when we need to finish. Yes, but does your plan support that type of finish? That's a tougher question to answer, and it needs to be answered when those constraints are used. The more constraints, when we see, let me say this in the right sequence here, when we see a project that didn't meet its baseline targets, we also tend to see a project that's used a number of hard constraints. Negative float, often the result of use and overuse of hard constraints. This is telling you that schedule completion is not possible based on the current completion dates, which can and should be driven by activity durations and activity sequence. If you have a baseline that has negative float, that means you are literally planning to fail. Now you'll have the PM, program manager, who says, well, we have to turn it up. We have to turn up the heat on this project. We're being challenged. We need to get done on time. That's why we're going to have negative float. To me, that's the wrong answer. The right answer is to look at that negative float and say, well, wait a minute. We're challenging ourselves, or we're being challenged, and we're showing negative float. We either need a better plan that meets the target date, or we need to turn around to management and say that it can't be done. Or it can't be done unless we have XYZ resources, dollars, etc. I won't accept negative float as the marching order. I won't. We need a plan that eradicates the negative float, or we need to decide that it simply can't be done. Negative float to me is an interim state before you do something else to fix the problem. It's not a state of existence. Insufficient detail. Activities with a duration greater than 10% of the total project duration. This is an indication of poor or unmanageable schedule definition. Once activities are too long, it's very easy to lose sight of what's being done at any given point in time during the execution of that activity. Well, if you lose sight of what should be being done right now, well, what resources do we need right now? Oh, I don't know. They're somewhere in that 100-day activity or multi-year activity. Well, That needs to be broken down into more specific detail so that the schedule can actually be used as the day-to-day management tool. If we have activities that are a year long, oh yeah, here's the activity we're doing right now. It's called design and it's over a year long. Okay, where are you in the design? Oh, I don't know, it's over a year long. Actual conversations that have taken place, you know, it's great to have that design summary in the schedule so we can see where design is taking place, but it needs to be broken down into more detail if it's going to be managed on a day-to-day, week-to-week basis. Again, unsuccessful schedules, we tend to see longer activities that exceed more than 10% of the total project in duration. Number of lags. This is non-working time between activities, and we use the example here, a good example here of concrete curing. For our cake, it could be the time in the oven. We don't have anything else to do. These tend to hide detail in the schedule. They also can't be statused like we status the other activities. More often than not, when I see a lag in a schedule, I see something that can be given an activity description, which lags don't get in your scheduling tool. I see something that can have resources assigned, which lags can't have in your scheduling tool. And then I become concerned that we're not managing that work to the same rigor that we're managing the other work in the plan. We're not saying lags are forbidden, and you might have a certain tolerance for them, but when I see a high number of lags, more than 5 or 10% of the activities in the schedule with lags, I become concerned that lags have been used as a planning methodology rather than an occasional exception, an occasional wait time, which is what I expect them to be used as. So I'm not here to say all your lags are wrong. I'm here to say when we see generous use of lags, we see situations where descriptions and resources could have been applied rather than hidden duration between activities. Number of leads. This is negative lags. This is always hard for me to get my head around because what you're saying with a negative lag is activity B can start usually slightly before activity A finishes. Well, there better be very strong communication between the owner of activity A and the owner of activity B, or they're not going to know exactly when the right time to start activity B really is. So we're not saying these can never be used. We do quickly become confused when they are used, and if we're confused, your team's probably going to be confused too. I see these used very often to crash a schedule and create delivery time frames that kind of are faster than the plan was actually made, but we see this as a substitute for you applying the right resources to actually shorten activity durations rather than what we're doing here, which is overlapping activities and running activities in parallel that may very well either not be able to be performed in parallel or are performed very inefficiently if they're performed in parallel. So we're not saying this is wrong, but what we are saying is when we see this, we see projects that didn't succeed. Merge hotspot, merge bias. How many things need to get done in the schedule before your activity starts? The more we see, the more of these items we see leading to your activity, the higher probability is that your activity is going to slip. If you're waiting for 2 things to start, that's not so bad. If you're waiting for 100 things to start, I guarantee you're never going to start on time. And the question is, did the plan really need to call for 100 things to get done before you started? Or were there really 2 that were the most critical items? And the other items were just nice for you to be aware of. This is where your schedule can be artificially longer than it needs to be. It also can be a situation where your schedule doesn't have the risk baked into it to show that any one of those 100 predecessors is going to slip. So I can't tell you just by defining this metric whether or not your task is going to start on time, but I can tell you, A, you might be using way too much logic to make your schedule robust, which is going to make it actually less robust. Or if those 100 predecessors are real, you better plan on many of them slipping out and actually finishing the project later than you anticipate. So that's why we call these a hotspot. we need it to be looked at. We need it to be reviewed for accuracy and for risk. Now there's a couple others that I want to talk about that are measured in a few different ways. So these are categories of metrics. Number one here is sound logic. We see things work best when activities are sequenced, where activity A finishes and then activity B can start. When we start applying lags or parallel logic, like when my starts, yours can start 2 days later. Well, what does 2 days mean? Why is it 2 days? How come it's not 3 days? How come mine doesn't have to finish first? I ask these questions a lot when I work with teams that develop schedules, and I don't usually get good answers because they're under pressure to meet a finish date. So they're trying to run activities in parallel that they might not have the resources or expertise to be able to do. So those start-to-start links where you can start the same times that I start. Well, don't I have to do something before you can start? Why is it that we can start at the same time? Maybe we can, or maybe more likely I need to finish first or get some amount of progress first before you can start. These lags that we talked about, they hide the schedule detail. You can start 5 days after me. Well, what happened in those 5 days? What's the milestone that needs to be accomplished in those 5 days? Let's define it that way instead of just saying, hey, 5 days after I start, you can start. Well, what if I didn't do anything for 5 days? Can you still start? Those are tough questions. They're not always easy to answer, but they need to be answered. Circular logic, out-of-sequence updates where the work's not really being done in the order that it was sequenced in. We have to start asking why. Open ends, when I'm using start to start, finish to finish. Too much logic, logic hotspots, redundant logic like we have illustrated here where it kind of turns into spaghetti logic. Why do I have this redundant link if I have these tasks sequenced? When I see a lot of that, I don't necessarily see something that's wrong, but I start wondering about the planning process and why there's so many links going in so many different directions. Good logic should be simple logic. It should be very easy to follow. And when I'm trying to follow this, it's like trying to follow a roadmap where the roads just kind of cross over and go everywhere. Well, if I'm going from here to here to here, does that mean I can go here too, or do I need to do both, or do I need this redundant link in here, or maybe I didn't need this logic? Why do I have it represented twice? Or did the team have the planning background to be able to sequence these activities since I'm seeing multiple paths to the same destination? Do we really know what we're building here? That's a more fundamental question. Durations and level of detail. This is another category of metrics. We talked about one such metric, which was insufficient detail. What's the average duration of my activities? What's the average remaining duration? There's an interesting characteristic here in this actual metric. The average original duration was 25. The average remaining duration is 26 days. Okay, one more day, big deal. Well, these are averages. The whole project grew an extra day based on the plan. On average, every single activity is going to take a day longer than planned. I'd love to be able to answer why on that right now instead of later on when the project actually finishes late. Let's find out what's going on. Let's finding out what the sand that's getting in the gears on this project that's causing, what is that, about a 4% inefficiency across the board in all my activities. Are we understaffed? Did we not understand the scope? Did we not sequence things properly so they're taking longer? Did we use a bunch of lags, but now the real activities, the real duration is actually taking longer because we had stuff hidden in the lags? This is stuff that you can monitor early and often, and having the right tools just to give you these answers is a lot better than trying to crank this stuff out by hand. I guarantee you'll never have time for a calculation like this unless the computer is just serving it up to you. Now, how do we know these things are bad or good, and how does your project stack up? Well, in our Acumen software, we can take your Fuse Schedule Index score, which is a synthesis of all these 9 metrics I've been talking about, and it gives you one number, 82 or 38 or 51 on a scale of 0 to 100. The example here, our score is 23. I tell you, that's not very good. It's only in the 15th percentile. That's pretty low. And in the 15th percentile, in our real database of real projects that we can compare you against, those projects in this case are only successful 10% of the time. So if my project scores 23 in the index score across those 9 metrics that I discussed today, projects that look like mine are only successful 10% of the time. Wouldn't it be nice to go back diligently to the planning process, plan better, score better, and then see a higher probability of success? It's not a guarantee. There's no guarantees in life. But wouldn't it be great if I made my plan properly, diagnose it, review it, build risk into it, so that it has the same habits and characteristics of projects that were successful? If I want to be an Olympian, let me go ahead and train like an Olympian and compare my training to Olympians that have been successful before me. Benchmark it. Rather than kind of do my own thing, go to the Olympics or go to the Olympic trials and lose in the first round of whatever my event is. I still might lose in the first round, but wouldn't it be better if I trained like the people who were successful, giving myself a better possibility to be successful? And that's what we're talking about here. Instilling the habits of successful projects into your project and measuring that along the way. So for this project that scores 23 on a scale of 0 to 100, let's not start executing it yet. Let's make it look like more successful projects before I go ahead and start executing it to give myself a better chance of success. Now, we still have to do all the hard work. We still need to execute the plan to be successful. But if we have a bad plan, I can almost guarantee you that you won't be successful. So let's go into battle. Let's go into project execution with a good plan. That's why we're doing this. That's why we're measuring this. So we can ultimately compare, diagnose, and correct. There's more coming. We're just getting into it today. It's tough to say that after 58 minutes of nonstop talking about schedule, diagnostics, and quality. But we actually have 3 more sessions coming up where we talk about more aspects of that S1 to S5 maturity framework. The next one coming up October 14th is risk management. It fits hand in glove with what we talked about today. Then we're talking cost, then we're talking optimization. And by the way, this whole series is based on this great book that we've just released called Planning a Great Project for Dummies. In fact, these sections mimic the chapters in that book so that you can download the book and you can follow along. You can read the book and then see our webinars as well as we emphasize the different points as well. So you can check that out at deltek.com/dummies. Easy to remember. Let's talk about another couple things too here. Deltek Insight 2014 is coming up, and it's coming up quickly, November 12th to 14th. It is a tremendous collection of thousands of people from the program and project-focused industries. We all get together once a year. This year is in Orlando. Head out to the website. We have a phenomenal keynote speaker this year. I can't believe we got this person. I don't know how they did it. I'm not going to reveal it, but it's up on the website. So go to deltekinsight.com to check that out. Jen's been answering questions along the way. We don't have time for live questions today, but if you do have questions that you think of in the next hour, in the next day, here's some ways that you can get in touch with us. You can get a free software trial of software that does the things and the diagnostics that we were talking about today. You can find out information on all of our program portfolio management PPM products. You can reach us on Twitter if you do the social media thing. And I know you've all got email. You can email us anytime at acumeninfo@deltek.com. Jay, over to you for wrap-up.
Thank you for joining us today, and please visit www.deltek.com for more upcoming Deltek events.